Welcome to my channel. Student, I saw a problem on AB about first order differentiation. Okay. The one who made the problem which is wrong in some step, he already said that. Now there is some basic concept need to know about the first order differentiation. Okay. First I follow my step and see where the step is wrong. Okay, the problem is f of x equal to root over sine x. Differentiate this with the help of first principle. Okay, now see, f of x is sine of root x, so f of x plus h is equal to sine of root over x plus h. Okay, so now f dash x is equal to limit h tends to 0 and f of x plus h minus f of x by h, and see this is x plus h minus sine root over x by h. He or she follow the step. He or she already done this step, and that's wrong. That's what right here. This is sine x plus h minus sine root over x. See, this is sine root over x plus h minus sine root over x. Here is sine root over x plus h minus sine root over x. Okay, this step is right here. Let's see how it possible. This is right or not. I want to show this step here broadly. This is limit x tends to 0. See sine square. Here see write this step sine square x plus h root over minus sine square root x over h times of sine root over x plus h minus sine root x. Okay, you know the formula from trigo. This is here sine square a minus sine square. Here is the step here. We can write here easily, that is sine of a plus b into sine of a minus b, and this is came from trigo. Okay, now so these properties, this is half times, this is 2 times of sine square a and minus 2 times of sine square b here, and that is equal to, we can write here, this is the multiple angle 1 minus cos twice a, and this is 1 plus cos twice b. So this is in the bracket, 1 or 1 are cancelled, cos twice b minus cos twice a, and apply the formula sin c plus sin d cos c minus cos d like that. Okay, 2 times of sine, this is 2b plus 2a by 2 into sine 2b minus 2a by 2. So this is 2b, 2a first, then 2b. Okay, 2 are cancelled. So we can write here sin a plus b and sin a minus b. And this is the right step. Okay, now we write this step here, limit h tends to 0. And this is here, we can write sine of x plus h plus root over sine x. And this is here sine of root over x plus h minus x by h. Okay, See this step here. Limit h tends to 0, sine of root over x plus h by into sine of root over x plus h minus root x. Okay. in place of h, you see wrote this step like that, root over x plus h minus root x. Very good. This is the right step. In place of h, right, we can write here root x plus h plus root x and root x plus h minus root x. So in place of h, the product we have h. So in place of h, we can write the product of these two terms into limit h tends to 0, 1 over sine root x plus h plus sine root x. But see, this step is 1, but this is never be 1. This is never be 1. According to the limit theorem, you know that sine limit x tends to 0, and this is here sine x by x. If we put 0 here and here, we always got 0 by 0 form. So we can get here the finite value always. But see, if we put h tends to 0 here, then we got here sine within the bracket 2 times of root x. If we put here 0, then this is 2 times of root x. यहाँ पे approaching value x not equal to 0, x tends to 0 नहीं है. So here is h approach to 0. So therefore this part cannot be 1 here. Okay. See. So this is the 1 here. So therefore in that step, so right here limit h tends to 0. So see, if we put 0 approaching value, h approaching value to 0 here, then we got here root over sine x, root over x minus root over x. So that's why sine 0. If we put here 0, then we got here root over x minus root over x. So this is we got here 0 by 0 form. So that's why it will be 1 here. So like that. Okay. Always you know this whole angle divided by this angle, when this whole angle is approaching value is 0. See, as here h approach to 0, so therefore root over x plus root over h minus root x is here approaching value is 0. But in that case root over x plus h plus root over x, this is not approach to 0. So this is approach to, if h tends to 0 and this is equal to 2 times of root x, this is can't be 0 here. Okay. So therefore we cannot take the limit of this here 1. Okay. See, if we put h 0, so therefore the value is here root over x plus root over x, and here is root over x plus root over x, and approaching value here, see, this is here 0, so we can write here the approaching value here is 1. Same as if we put here 0, then we got here sine root over x plus sine root over x. See, so this is here sine 2 times of root x whole divided by 2 times of root x and 2 times of sine root x. From the multiple angle, we can write here 2 into sine root x and cos root x. This is 2 root x This is 4 times, 4 times, 4 times, yes, 4 times of sine root x. See, these are cancelable. So we got here cot root x, cos root x divided by 2 root x. Okay, this is your answer. So see carefully, this is never the 1. This is the approaching value is sine 2 root x by 2 root x. As we see here, x does not approach to 0. So if x approaches to 0, then we can write here 1. But here is h approach to 0. See carefully. Okay. So this step is here wrong. Okay, I think a little bit understood. Bye everyone.